Hello learners, welcome to Education Online program. I have teacher Willa Lucia. So in our previous lesson, we learned about momentum. We say that momentum is the product of mass and velocity. We went ahead and looked at the principle of conservation of linear momentum. We also looked at collision. So we had the types of collisions. So we covered only we said inelastic collision, but then we did not talk about the elastic collision. So today we are going to continue from there. Types of collision. We say there are two types of collision, where we have the inelastic collision, where we say this is a collision where two bodies it can be two or more than two, so let's just talk of bodies. Stick together after collision. So that was with an elastic collision that we covered yesterday, and we say to get this, to get the velocity with which the bodies are moving here, we shall first conserve momentum, where we shall have the momentum before collision in case there are two bodies, and then we shall have equaling to the momentum the bodies were moving with. Since the bodies stick together, we add the two masses and multiply it by their same velocity. So here we shall have our velocity is equals to the mass of the first, then the momentum with which the second body was moving, then we divide all this by the two masses. This can be m1 and m2. So that is how we get the velocity when the bodies actually stick together. So let's look at elastic collision, which is the second type of collisions. We have elastic, with elastic collision, what really happens? Elastic is the opposite of this inelastic. You find out that with elastic collision, when the two bodies crash into each other, they are not going to stick together, but this time round they will separate. When they separate, what happens? You will see that they move with different velocities because there the two bodies are not together. So you see each body takes its own direction, even though they take the same direction, but then they will be moving with different velocities. So we shall say with elastic collision, this is a type of collision where this is a type of collision where bodies separate after colliding. So if these two bodies separate after crashing into each other, what happens is that they will still conserve momentum there. So the principle of conservation of momentum will still apply to elastic collision. So you'll see also that there is what is known as the kinetic energy. So they also conserve that kinetic energy. So let's see how they conserve that. We consider a body. If we consider a body we are going to consider two bodies of masses m1 and m2 moving with velocities of u1 we have u1 and u2 respectively. After collision, the bodies move with velocities of v1 and v2 respectively. So we say that with elastic collision, they conserve linear momentum. Let's see. Let's first consider their first momentum. At what rate were they moving? What was the momentum of the first body, where we're saying the mass is m1? At what momentum was it using before it crashing into the second body? And even the second body, you find out it was already moving, because we have velocity there that the bodies were moving. So if they were moving, what were their momentum? So we are considering that to be their momentum before collision. So you'll see that we are going to multiply the mass and their velocities before collision, which is the u1 and u2. Then we add the two momentums to get the total linear momentum of the two bodies before colliding. So let's see. Before collision, we shall have momentum of the first body will give us the mass of that body times the velocity with which the body was moving. So we shall have our m1 is the first body, and it was moving with a velocity of u1. So we also have the momentum of the second body, which will give us the mass of that second body times the velocity with which the second body was moving. So if we have these two, we have the momentum of the first body and then the momentum of the second body. How can we find the total momentum of these two bodies before the collision? So to find the total momentum, we shall add the two momentum of the bodies. So we shall have it, our total momentum before collision will be equaling to the momentum of the first body plus the linear momentum of the second body. So you see, adding these two gives us the total momentum of these bodies before crashing. So what if now they say after collision the bodies move with velocities of v1 and v2? Which velocities are those? Those are the velocities the bodies attain after them crashing into each other. They separated and started moving at different rate. So what were their momentum again? Does it increase or reduce is what we shall see. So we shall have our momentum. This was before. So we have after collision. After collision, the momentum of the first body will be equaling to the mass of that body and the velocity, the speed that the body used after them colliding, which is the V1. We shall have it here as our V1. Then we also have the momentum of the second body, which will give us the mass of that body. And after them crashing, what happens to the second body? It started moving with the velocity of V2. So we shall multiply it by the mass of that body. So we shall have our total momentum. The total momentum after collision will be the momentum of the two bodies. So we shall add our M1 V1 plus M2 V2. So adding these two gives us the total momentum they were moving with after them crashing. So how shall we conserve the principle of linear momentum here? So if we want to conserve that, they are saying that with the conservation, the total momentum and the total momentum before collision will be equal to the total momentum after collision, because these two momentums remain actually constant. That is in a condition that there is no any other external force that has been applied to the bodies. So we shall have it as we shall have our momentum, our total momentum, before collision, which will be equaling to the total momentum after collision. So before collision, what did we have? We had our M1 U1 plus our M2 U2, which will be equaling to M1 V1 plus M2 V2. You'll see that here it is with the elastic collision, it is actually a bit different from the inelastic, because with the inelastic you saw that the total momentum after before collision is actually like that. But then if you come to the momentum after the two bodies colliding, instead of us having V1 and V2, we are having only the masses, mass of the two bodies, two or more bodies, and then multiplying by the V, because here for them with the inelastic they were moving with the same velocity, but then here we are saying they move with the different velocities. So this is the formula we shall be using for elastic collisions. So whenever there is any question that is saying that the two bodies actually separated after them colliding, you apply this formula here. But then if we say that they stick together moving with the same velocity, that means that the two bodies they have undergone an inelastic collision. So you will also use that formula of inelastic collision. So let's take a look at this example here. We are saying a body of mass 4 kilogram moving with a velocity moving with a velocity of 25 meters per second collided with another body of mass, of 5 kilogram, moving with a velocity of 40 meters per second from the opposite direction. If the 4 kilogram mass moves with a velocity of 10 meters per second after collision, find the velocity of the 5 kilogram after collision. So we are saying that a body of mass 4 kilogram moving with a velocity of 25 collided with another body of mass 5 kilogram moving with a velocity of 40 meters per second. But then this body is moving from the opposite direction. If the 4 kilogram mass moves with a velocity of 10 meters per second after collision, find the velocity of the 5 kilogram after the collision. So here they are saying we had two bodies. This is our body 1 here. And we are saying that the mass of this body is what? If you come to check that, the mass of our first body is 4 kilogram. So we have this body of 4 kilogram here. It was moving with a velocity of 25 meters per second. So it was given a velocity of 25 meters per second. So if it is moving with a velocity of 25 meters per second, what happened? It collided with another body of mass 5 kilogram. So if it collided with this body, how was the body moving? The body was moving with a velocity of 40 meters per second from the opposite direction. So this other body here is of mass 5 kilogram. So what happens is this body was moving in the opposite direction. This arrow here is showing us the direction this first body is taking. So you see that our arrow is facing that way. That means that it is taking that direction. With this second body, it is moving opposite to this first. So we are having it moving this way with a velocity of what? It's moving in the opposite direction with a velocity of 40 meters per second. So our velocity here is 40 meters per second. If the 4 kilogram mass moves with a velocity of 10 meters per second after collision, So you see that when these bodies move, they reach a point, they end up crashing into each other. So when they crashed, what happens? This other body, they did not stick, but then they separated. If they separated, one of the bodies, which is the 4 kilogram, started moving again with a velocity of 10 meters per second after them crashing and separating. But what of the second one? What was its velocity? Which velocity did it attain? What speed was it moving with after they have crashed? So that is actually what we are going to find. So we see that after collision, this second body here moved with the 4 kilogram, started moving with a velocity of 10 meters per second. But what of this other body of 5 kilogram? It is moving with a velocity that we don't know. So it is what we want to find. So for us to find that, we need to conserve momentum. How do we conserve this linear momentum? During the conservation, we say that the momentums remain constant before and after collision, provided there is no any other external force. So let's see this. We shall have a momentum before collision. So what is the momentum before the two bodies are colliding? To get this momentum, since there are two bodies, we shall also have two momentums. Then we shall add the two together to get that total momentum before them colliding. So the momentum before collision, we are going to first get for the 4 kilogram mass. So to get that, we shall have our M1, U1, its velocity. So what is that? We have the mass of this body as 4 kilogram, and then we also have the velocity with which it was moving. So our velocity there is 25 meters per second. So we have it as 25 meters per second. What shall we have? If you get your 25, multiplying it by 4, we shall have 4 times 5, which will give us 4 times 5 will give us 20. We write our 0, we carry the 2. So we have 4 times 2, we shall have 8. 8 plus 2 gives us 10. That means that our 4 times 25 is equals to 100. So this is our momentum before of the first body. Don't forget the SI unit. So let us see for the second, for the 5 kilogram mass, will give us the mass of this body and the velocity with which it was moving. So we shall have the mass is 5 times the velocity, which is 40. So if you have your 5 times 40, what shall we have? Let's see. We have 40 and then 5. We have 5 times 0, which will give us 0. 5 times 4 will give us 20. So we shall have it as 200 kilogram meters per second. So that was those were the velocity, the momentums the two bodies were moving with before them colliding. So we shall have our total momentum, the total momentum before collision as we shall have the momentum of this and then this. So we are going to add the two, which will be equaling to 100 plus 200. So we shall have it as 300 kilogram meters per second. That is the total momentum for the two bodies. Let us see after colliding what happens. After collision, we are saying they moved with separate velocities. So let's get the momentum. Momentum after collision. We shall have the momentum of the first body. Let's take the 4 kilogram mass. We shall have, for the 4 kilogram mass, which will give us, we shall have our mass m, and then the v, the final velocity it was moving with after them crashing, which will give us the mass still remains 4 times the velocity here is what it started moving with, a velocity of 10 meters per second. We have 10, so we shall have it as 40 kilogram meters per second. So let's look for the at the 5 kilogram mass. So it is what we don't have, but we have the mass, and then we need to find that. So it's still our mass of this body is 5 times the V2 we don't know, to have 5 V2. Now we have to add to get the total momentum of the bodies after collision. We shall have our total momentum, a momentum after collision, which will give us 40 plus 5 V2. So if we have that, let's conserve momentum. We shall have the total momentum after momentum before equaling to total momentum after. So what do we have as our total momentum before? We have it as 300. So we shall have here our 300 equaling to this other total momentum after the two bodies colliding. We shall have it as 40 plus 5v. So we shall have it here as 40 plus 5v v2. So if we have it like that, what happens? We try to make 5v the subject by subtracting 40 from both sides. So we shall have it as 30, 300 minus 40 equaling to 5v. So we have it here as our 5v2. So we can get out here, we shall have 300 minus 40. What shall we get? We shall have 260. So if we have 260, we shall have it here as 260 equaling to 5v2. So we divide through by the coefficient of v. So what is our coefficient of v? You find the coefficient of v is 5. So we shall have it as 260 equaling to 5v2. Then we divide this by the 5 and then divide here by 5. We shall, this one will go, so 5 will go here once. How many times does 5 go into? Into 26. So you see that 5 goes into 26 5 times. If it goes 5 times, does it have a remainder? Yes, it has a remainder of 1. So how many times does 5 go into that? We shall see that it goes 2 times. So we shall have our V2 equaling to 52 meters per second. Meaning that when you conserve the momentum, you're going to get the velocity they want you to find with. So after the two bodies colliding, our first body moves with a velocity of 10 meters per second, then you see that the second one will move with a velocity of 52 meters per second. So is there any reduction in that, in their velocities? If you check here, at the first body, it was moving with a velocity, this is the 10 after, but then before it was moving with a velocity of 40. That means that there is a reduction in their speed. Their speed was reduced after them coming into contact with each other. Even if you check the second, it was moving with a velocity of what? At the first time, it had a higher velocity, but then you come and check the second one, there is for the second one there is an increase. So that is how you get the momentum. Always make sure you conserve the momentum with elastic momentum, with elastic collision, and then you can also conserve the kinetic energy. It is not like the inelastic collision where you only have to conserve the momentum, but then there the kinetic energy is that conserved. So with this we come to the end of our lesson, and we shall meet again in the next lesson.